All right, guys, we'll do some NOAA buoy review here on how to get a model accuracy analysis on a NOAA buoy. So what we'll do is we'll go to the NOAA buoy site, which is right here, and there's a lot of buoys. We could look down at a buoy right here, down in the Florida Keys, but you'll notice there's no true wind speed and true wind direction on this buoy. Not every buoy has true wind speed and true wind direction. The red means that there's no buoy data that is recent, but right here we have the Virginia Key Station, and that looks yellow, which means that it's good. And look at that, it does have true wind speed and true wind direction. So if I were to click on that and view the details, I would get this page right here. And it's yellow, so it says that its information is current. And we'll scroll down and we'll check, okay, it's got good true wind speed and good true wind direction, and that data is coming in about quite a bit. Looks like every 6 minutes or so, we're getting true wind speed and true wind direction from that reporting station. That's terrific. So we will need to remember this code right here, that VAKF1, that is the station identification, and we see an anemometer height of 10.2. So we will need our internet connection for this. We're going to close out of this, and we'll make a new race folder, Virginia Key NOAA buoy, and we'll leave that right there. We're going to click on the NOAA format. So we have to put in that VAKF1. It has to be all capitals. It is case sensitive, and we're going to select the fetch data. That fetch data is going to go out and it's going to pull the last 5 days of NOAA buoy data into our log file. Now I have an empty folder here, and this is where I want model accuracy to download that NOAA buoy data log file, and I want it to create the format that I need in this empty folder. Remember, even though we don't have the log file already on our desktop in a folder, we have to tell model accuracy where we want it to download that weather file to and work on it. So we're going to say work on that VAKF1, that's the buoy code, and do all your work in that empty folder right there. Now I've downloaded some GFS GRIB files, and I have them in the NOAA GRIB file folder. So here are my NOAA GRIB files for the last few days of just GFS, and then here is an empty folder where model accuracy will work on that NOAA information. Now, NOAA records everything in true. We'll leave log data smoothing at none. And the anemometer height we don't need to use. We're going to click prepare data, and it's going to start working on it. Oh, and it's given us an error saying, or a warning saying it's going to set the anemometer height to 10.1 from that NOAA buoy. And remember, we saw that on the website. So automatically, model accuracy will automatically calibrate your anemometer height to whatever the NOAA buoy setting is for you. Everything else is pretty easy. We still want our true wind speed, true wind direction. I don't really care about the barometric. Let's see, we got a recommended start time, a recommended end time. My GRIB files only start about 4 days ago. The analysis end time will end at 15:12 Zulu. And that's about an hour here. So this is 16:15 Zulu down on my computer. So it only goes to about an hour back in time. It doesn't go right to the last most recent moment. That's just one anomaly with the NOAA GRIB with the NOAA buoy data. We'll click the plots. We'll click save. I think we're good. We'll click analyze, and stuff should pop up pretty quick. So there is our true wind direction and true wind speed. True wind speed, you can see we're doing just GFS, which is always green, and there's the data right there. Looks like the forecast was always a little bit saying it was going to be windier than it actually was. The black line is the NOAA buoy data. True wind direction, it did a pretty good job of getting a big right shift. It just kind of kept coming, and it even got a little bit of a left back in there too. So true wind direction's doing pretty good. And then you can see all the errors, and the NOAA data source is the NOAA buoy. Gave us a nice model accuracy error, good calibration on true wind direction, and we're pretty happy with that NOAA function. So we'll click out of the analysis and we'll show you, remember this folder was empty before, and now it has two formats. It downloaded the data as a text file, and then it created it into a CSV file, which you can see right here. So this is what it went and got from the NOAA buoy data, and it turned it right into the same UTC format, very similar to that of what we use in Expedition. So that is your NOAA buoy data function.